Hello everyone, and we're going to continue our discussion of Unit 9 on global change today. And today we're going to do that by exploring another example of global change, something we talked about literally on the first day of school, and that is global climate change. Now you should be pretty familiar with what this is and be able to identify different components of it based on how we've been talking about it all year. But today we're really going to get into the nitty-gritty of what it is, how it works, and what the impacts are, as well as what we can do to stop it, because it's probably one of the biggest threats that we face as a people and as a world, not just humans but other organisms and creatures as well. So global climate change, what is it? It is large-scale change of the Earth's climate, or climate, which is just long-term weather patterns, right? The core of this issue, it comes from increased carbon dioxide in the atmosphere, which is going to lead to increases in temperature, increases in the sea level, increases in the acidification of the ocean, as well as a wide variety of impacts that follow those three things. But in order to understand how climate change works, we first need to understand something we've been talking about all year long, the greenhouse effect. So let me orient you. This is a little diagram here. At the bottom, I've got Earth, nice green circle. Above the Earth, I've got the atmosphere in which we live and breathe. And there are lots of different gases flowing around in there. And above that is space with the sun. Okay, normally what's happening on Earth is that the sun's rays, solar radiation, comes down from Earth, goes through the atmosphere, comes down from the sun, goes through the Earth's atmosphere, hits the Earth's surface, and it warms the Earth's surface, right? And as the Earth warms, it will also release heat in the form of infrared radiation, kind of like the same way that your body radiates body heat. Now, the atmosphere has gases in it called greenhouse gases, some of which can actually absorb and reflect some of that heat, which will cause the atmosphere to warm. And this isn't in itself a bad thing, right? This is basically the greenhouse effect, this idea that these gases, greenhouse gases, will trap heat in the atmosphere, much in the same way that a greenhouse traps heat in the glass panes, allowing you to grow different tropical plants all year round, even in a cold weather. So the issue isn't that the greenhouse effect exists, because it's actually essential for the survival of life on Earth. Without it, the Earth's surface would be about 60 degrees colder. So life on Earth would not be able to persist if it were not for the greenhouse effect. So that's not the issue. The issue is that the greenhouse effect is kind of getting out of control. It's being intensified by human actions, and so this heating of the atmosphere we see is actually getting really, really bad. So let's walk through why that's the case, and I'll take you back to that diagram. So greenhouse gases are at the root of this problem because we're seeing an increase in the amount of greenhouse gases. Here are some of the four main greenhouse gases: carbon dioxide, methane, nitrous dioxide, or NO2, and chlorofluorocarbons, or CFCs, which we talked about in the last Edpuzzle. And each greenhouse gas has a data value we can apply to it known as their global warming potential, which is basically their ability to absorb and hold and trap heat in the atmosphere over a period of time. And this is going to depend on the molecule's structure as well as its residence time, how long it lingers in the atmosphere before it breaks down, dissipates, etc. So for the standard, the baseline is set by CO2, or carbon dioxide. We say that has a global warming potential of 1, whether it's on a scale of 20 years or a scale of 100 years. Carbon dioxide has a global warming potential of 1. And if you look in relation to that, methane on a 20-year scale is 86 times worse than CO2 in regards to global warming, meaning that it will, for every 1 molecule of methane, that is equal to 86 molecules of CO2 in terms of the potential to contribute to global warming. And you can see that nitrous oxides are worse than that, and CFCs are much, much worse than that. Now, if you look over a 100-year span, you'll see all these numbers decrease. That's because these molecules will start to break down and dissipate. But something to keep in mind is that carbon dioxide has a very, very long residence time. We're talking hundreds to possibly even thousands of years. So the potential for carbon dioxide it lasts a really long time in the atmosphere, right? Additionally, water is technically a greenhouse gas, but because it has such a low residence time, it doesn't really contribute to climate change. So if all of these gases are way, way worse than carbon dioxide in terms of warming the Earth, why do we care so much about CO2? Well, I already gave you one piece. CO2 lingers for a very long time. It's got a very high residence time. And the second reason is because we're producing way more CO2 than we're producing of any of these other gases. I don't know exactly what the ratio is off the top of my head, but I'll show you some graphs in a little bit because CO2 is a product of fossil fuel combustion. So when we have an increase of greenhouse gases in the atmosphere, this is what we see. We see solar radiation coming from the sun, warming the Earth, and the Earth emits that infrared radiation. Some of it does escape, but because we have increased greenhouse gases in the atmosphere, more of that heat is going to get trapped. And so the atmosphere is going to warm to a dangerously high level. And we're not talking 80,000 degrees hotter. We're talking 1 degree hotter, 2 degrees hotter Celsius. That's all it takes to start to see really dramatic impacts on the globe. So, too long, didn't read, I didn't watch the first 5 minutes of the video. There are certain gases in the atmosphere that trap heat in the troposphere. Too much of those gases causes the Earth to overheat on a global scale, generally speaking. That's what we refer to when we refer to global warming, although that does not mean that all of the Earth will be getting equally hotter. We might see changes in other places as well, as I'll talk about in a minute. Here's a diagram summarizing what I just talked about with the greenhouse effect. So how does this connect to climate change? Well, this is kind of at the root of climate change. Climate change is caused by increased temperature, and that increased temperature is due to excess carbon dioxide from which contributes to the greenhouse effect. And the greenhouse gases, especially CO2, but also methane, NOx, and CFCs are increasing due to human activity, right? This should not be surprising. We've been talking about fossil fuel combustion all year long. And if you look at this graph, we've got on the x-axis we've got time, on the y-axis we've got the concentration of carbon dioxide on the y-axis. And this is a very famous graph. It's called the Mauna Loa curve because it is a measurement of carbon dioxide in Hawaii over the past 70 years or so, and you can see a pretty dramatic increase in the concentration of carbon dioxide from under 320 parts per million all the way up close approaching 400 parts per million. So we're seeing an increase in carbon dioxide. And a lot of that carbon dioxide is coming from human activities, almost all of it. Some of it comes from forest fires and volcanoes and things like that, but a lot of it comes from the mixing of cement, if you can believe it or not, as well as fossil fuels, coal, natural gas, and petroleum. When you burn those, you produce CO2. So it's really all about fossil fuel combustion. That's where a lot of the CO2 is coming from. Make sure you understand that if you don't already. Now, just so you know, there have been fluctuations in the CO2 levels and the temperature of Earth for hundreds of thousands of millions of years. The Earth is very old, and there have been changes in the climate throughout geologic time. And there have been major shifts in the global temperatures, like the Ice Age. So it's not like the Earth this is the first time this is ever happening, where you're seeing periods of warming and cooling. And we know this because we can actually record CO2 data and temperature data using ice cores. I talked about that at the beginning of the year. It's not super important that you know that, but although we see all these fluctuations, if you look at this graph on the y-axis, we've got time, but we're going back in time. So on the far right is 0, that's today, and as you go further to the left, you get further back in time. And then we've got CO2 concentrations in red and temperature in yellow. So you can see there's been a lot of variation over the last 400,000 years, but what we also see is that more recently, a very dramatic change. As of 1994, we're seeing the growth rate, the slope of this line is extremely, extremely high, both for the CO2 concentrations and the temperature, and the projected increase in CO2 for 2100 is really, really, really high. So that's the concern, is not that the Earth is changing its climate, but that it's changing at an extremely rapid rate, faster than we might be able to adapt. So why is the increased temperature due to the greenhouse effect a problem? Oh, where should I start? Well, first of all, it's going to lead to large-scale global climate change, which at this point should be a no-brainer for you. What does that actually mean, though? Climate change. Is it going to just be a little bit hotter in the summer? Well, in the short term, yeah, and that might not be such a bad thing. But in the long term, we're going to see some pretty serious impacts. We're going to see the melting of permafrost, which can release methane. The ice caps in the glaciers melt, which will contribute to sea level rise. The influx of cold and fresh water from those melting glaciers could change the ocean currents. The melting of those glaciers is going to lower the Earth's albedo, or its reflective capability, and the sea level rise that results can displace coastal populations and destroy ecosystems. We're also going to see, as it gets warmer, that the water is going to expand in size, which will contribute to sea level rise. We're going to see, as temperature changes, that the species around the Earth, their range where they can live habitably due to their ecological tolerance to temperature, is going to shift. So disease vectors such as mosquitoes might spread from the equator and towards the poles, towards the direction where we live in the United States. We're also going to see changes in the wind currents, such as the jet stream or Hadley cells. We might see changes in soil temperature, soil moisture, and soil health, which could possibly lead to erosion and issues with crops. And we might see that increased temperature is going to lead to death. Children and elderly, especially in urban areas, are much more likely to die due to heat stroke. So let's go through some of these. Drought. As it gets hotter, more evaporation, less water on the ground, which can lead to starvation due to decreased crop yield or people just not having enough water to drink. I also mentioned melting permafrost. Permafrost is permanently frozen soil in the polar regions of the Earth, mostly the Arctic, northern Canada and stuff. And oftentimes there is methane gas frozen, trapped inside that permafrost. But as the Earth warms, that is going to start to melt and start to release that methane gas. Here's a video. You can see they're releasing some methane gas from permafrost and lighting it on fire. It's natural gas. It's extremely flammable. So we start to see that, oh, well, if more methane is released, that means there are more greenhouse gases in the atmosphere, which will mean warmer temperatures, which means more ice melts and more methane released. This is an example of a positive feedback loop. We also see another positive feedback loop with the melting of sea ice. The polar regions of the world are more vulnerable to climate change because of a positive feedback loop having to do with albedo. We talked about this literally the second day of school. Albedo is the measure of a reflectivity of a surface. Something with a high albedo is very reflective. And so what we see in the Arctic is that the ice is white, it's reflecting a lot of solar radiation, it has a high albedo, that's good. But as the temperature gets warmer, the ice is going to melt. And what's underneath ice but the water, the ocean. And the water is a very, 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 very dark blue here. So that has a very low albedo, meaning that's actually going to absorb more of that energy, that heat energy, and reflect less of it back into space, which is going to cause these temperatures to increase even further, right? This is an example of a positive feedback loop, a vicious cycle, a snowball effect. It's running away, and it makes the polar regions very vulnerable and more susceptible to climate change. Here's a diagram depicting that, right? As the temperature gets warmer due to the greenhouse effect, the ice will melt, which means that there's a darker sea surface exposed, which is going to absorb more heat and lead to increases in temperature. So we should be concerned about this positive feedback loop, and you can see the impacts of it. So we've got a graph here. We've got year on the x-axis, 1900 here, 1910, 1920, all the way up to 2010. And on the y-axis, we've got the volume of Arctic sea ice as in terms of its deviation from the average over this last 50 years or so. So the red line represents no change from the average, and you can see that there is a decrease from the 1900 to the 1940 time, and then it fluctuates a lot. But in the past 40 years, 50 years or so, since the late 70s, we've seen a pretty drastic decrease in Arctic ice, and it's not really bouncing back too much, right? A lot of the times you see it go down, it bounces up again because it refreezes in the winter. We're not really seeing that here. And in a lot of these Arctic communities where indigenous Alaskans live, they have ideas and science that can actually help to illuminate some of these issues, and they're trying to demand a voice in the climate change research, particularly that surrounding the melting of Arctic sea ice. Additionally, as the ice melts, that's going to put more water into the ocean, which is going to cause the sea level to rise. Another cause of rising sea levels is ocean thermal expansion. When you have a liquid that gets hot, it's going to expand in volume. If you leave a soda can in your car and it gets hot in there, the can will explode. And it's the same idea if you boil water. As the water turns to a gas, it will expand in size, which is why the lid can bounce off. Right? So those two things, the melting of the sea ice and ocean thermal expansion, are leading to sea level rise, which is dangerous for a lot of reasons. In terms of coastal communities of both organisms and habitats and ecosystems, but also humans. Now, this could have interesting impacts on marine ecosystems. It might create new habitat on land that is currently land, and in the future it might end up flooded, might end up as new marine habitat, creating new habitat. That's kind of exciting. But it also might destroy coastal habitats by flooding them with salt water. It might mean that as the sea levels rise, communities that are going to be now, relatively speaking, deeper, and so they're no longer in the photic zone, meaning light is no longer penetrating that deep, so they're no longer able to photosynthesize or what have you. Also, it could lead to habitat loss. Many organisms, like polar bears and seals, rely on the ice to hunt or live or sleep. But also, the sea level rise will destroy coastal communities, which can reduce habitat. And as the temperature rises, we might see habitat being destroyed as well, as organisms are no longer able to survive there because it is too hot. And that includes humans. Whether it's increased temperature or sea level rise, we're going to see mass migrations of humans from certain areas of the globe, particularly coastal ecosystems like Louisiana and Florida that are very flat, as well as Bangladesh and other island nations like Fiji are very flat and susceptible to flooding, but also places like Arizona and areas around the equator are going to get a lot hotter, so people are going to need to leave there. They're not going to be able to survive. Whether you're living on the coast, like some of these communities, a foot of flooding could really damage this community. You can see they're building their house on stilts, and they often have to truck in sand to rebuild these beaches every few years because they get eroded by the ocean. So as the sea level rise, these communities are at risk. But we also see that the area in which you can't live because it's too hot is going to grow. Today, 1% of the world is in a barely livable hot zone, too hot to survive. By 2070, that could go up to 19%. So we're going to see a large change in the areas of the world that you can't live in because it's too warm. And places like Miami that are in danger due to coastal flooding are doing things like raising their sidewalks and building generators and seawall barriers and stuff like that. You can see some raised sidewalks here and here, but these are short-term solutions to a long-term problem. Additionally, climate change, not only in sea level rise, is going to see changes in the wind patterns as well, whether it's a Hadley cell, which we've talked about before, or the jet stream. The jet stream can help carry heat around the globe. It is a massive wind current that flows from west to east across the northern United States, and adds more energy due to rising temperatures. That's going to increase the energy of this current. It's going to disrupt the current, so instead of flowing in a kind of smooth line, it will start to flow in a more wobbly line like this. I like to think about it like if you have a piece of rope on a table and you push it slowly, it will stay pretty straight. But if you try and push it really fast, boom, it will all bunch up like this. And that's what's happening, is this increased temperature is putting more energy into this, which is causing it to bunch up. And what that means is, if you look, you may have heard about the polar vortex, which is a circular wind pattern of cold air at the North Pole. And when the jet stream fluctuates like this, that allows colder air from the polar vortex to come down more south. The jet stream is a nice barrier protecting us from the polar vortex. So we're actually going to see, in some cases, parts of the United States getting colder than usual due to the polar vortex. We'll see similar patterns with ocean currents. I've talked about this probably 2 or 3 times now. The ocean conveyor belt carries heat around the Earth. We've got the Gulf Stream, which travels up from the equator across the east coast of the United States to Europe, bringing warm water and warm air to Europe, making Europe much, much warmer than it should be because of the Gulf Stream. Compared to across the sea at a place like Canada, Europe, like England and Ireland, is much, much warmer. But as the glaciers in Greenland melt, that's going to inject cold water and fresh water into these ocean currents, and ocean currents are often driven by temperature and salinity, so it could disrupt the Gulf Stream, causing Europe to become much colder. We're also going to see changes in soil health. As it gets warmer, there's more drought. We might see more rainfall in some areas. We might see less rainfall in other areas. This could increase erosion. It can negatively impact the ability for us to grow in the soil. So what do we do about all this? There are important small things that you can do as an individual. Voting, spreading the word, educating the people around you. That's really, really important. You know, and if your voice gets loud enough, you can reach a global scale like Greta Thunberg. But more importantly, we need large-scale action. Legislation, like these three pieces that I'll go through in a few seconds. We need to shift towards alternative renewable energy away from fossil fuels. That's the big thing. We need to focus on ways to reduce the amount of CO2 and other greenhouse gases that are currently in the atmosphere, whether that's through carbon capture, using brand new technologies, or by planting trees and protecting forest ecosystems that capture a lot of carbon. They're carbon sinks. So let's talk about these three pieces of legislation. This one you definitely need to know. The Kyoto Protocol of 1997 was an international treaty organized by the UN to fight climate change and by setting goals about greenhouse gas emissions and temperature goals. Most of the countries have signed and ratified it. The United States, interestingly, has not ratified the Kyoto Protocol. However, they did join, the United States did join the Paris Agreements in 2015. Very similar to the Kyoto Protocol, just more up to date as the international treaty to fight climate change, reduce emissions, help different countries adapt and respond to the impacts of climate change. And one of their main goals is to keep the rise in temperature below 2 degrees Celsius and ideally below 1.5 degrees Celsius. Now, the United States left the Paris Agreement during the Trump presidency. I don't remember exactly what year, but they recently rejoined it as of 2021 when President Biden was elected. This is not a compulsory thing. It's not like the countries, if they don't meet their goal, they're going to get punished. It's just sort of like everybody coming into the room and shaking hands and saying, okay, like, let's do this, let's work together, set goals, and try and hold each other accountable. But there's not like a punishment if we don't meet the goals. So there's really no reason to not be in the Paris Agreement. And if you're wondering about 2 degrees Celsius, we can keep temperature below that. That's not even that big of an increase. So what if we get 2 degrees Celsius warmer? Well, let's go through some of the differences we might expect to see around the globe if we get 1.5 degrees Celsius of warming versus 2 degrees Celsius of warming. If comparatively, it's a difference of about a couple weeks of heat waves throughout the year, the difference between 1.5 and 2 degrees Celsius of warming. A substantial decrease in the availability of fresh water in the Mediterranean. A substantial increase in the amount of heavy rainfall in certain parts of the globe, substantial decreases in crop yield in terms of corn, wheat, but we will see increase in production of soy and rice. And you can see the differences. Wheat production is down 16% at 2 degrees Celsius. It's only down 9% at 1.5 degrees Celsius. That's almost double. So it's a pretty big impact. Sea level rise will be 50 centimeters versus 40 centimeters at 1.5 degrees. And we will see less damage of coral reefs through a process called coral bleaching, which I'll talk about in the next video. So the difference of 0.5 degree can actually make a very, very big difference on a global scale. So don't let that fool you. 2 degrees is a lot. And the last one I want to talk about is the Green New Deal. You've probably heard about this. It's been highly politicized in the media. It's a proposal that calls for change in public policy to address climate change, proposed by two Representative Alexandria Ocasio-Cortez and Senator Sid Markey. She's from New York. He's from Massachusetts. And this, much like the Paris agreements and the Kyoto Protocol, it's non-binding. It's not. And currently, it's not even a law. It's just a proposal. It's just a group of people came together and say, hey, this is what we want to do to move the country towards a more sustainable economy. And while this one focuses on the United States, there are Green New Deals in other countries that have been popping up since, I think, 2001. So this is not a new idea. And their basic goals are to push towards sustainable economy, get towards net zero greenhouse gas emissions. So meaning that even if we're putting CO2 into the atmosphere, we're removing the same amount, so we're not adding any new CO2 to the atmosphere. and to get towards 100% renewable energy by 2030. Some of the criticisms follow this goal, which some people say is unrealistic. There are a lot of myths around this, that this plan will eliminate planes or cars or the military or ban hamburgers and cows. That's not true. There are connections. Obviously, we talked about the climate impacts of meat and the release of methane from cows, trying to reduce our meat intake, but this plan does not try to ban cows. So that's a total myth. But what does it do? Let's go into some specifics from the policy itself. I pulled these from the policy. Here's one quote. The goal to create 20 million jobs in the United States by transitioning to 100% clean, renewable energy by 2030, investing in public transit, sustainable or regenerative agriculture, conservation and restoration of critical infrastructure such as roads, as well as ecosystems. Additionally, they want to focus on environmental justice, implement a just transition that empowers those communities and workers most impacted by climate change, and the transition to a green economy. So they're going to ensure that any worker who's displaced by the shift away from fossil fuels will actually receive full income and benefits as they transition to that alternative work. So that way people who are working in coal right now, if they wanted to become trained to become like windmill technicians, that would be accounted for in this policy. Additionally, they want to end destructive energy extraction associated infrastructure, including fracking, tar sands, offshore drilling, oil trains, oil pipelines, mountaintop removal, natural gas pipelines, uranium mines, etc. Halting any investment in fossil fuel infrastructure, including natural gas, and phase out all fossil fuel plants. Also, interestingly, phase out nuclear power and end nuclear subsidies. This is another big point here. End all subsidies for fossil fuel and impose a greenhouse gas fee or tax to charge polluters for the damage that they create. So it's kind of like a cap and trade, just a little bit more intense. Now, like I said, this policy has been criticized by actually a lot of people who are on the political left of the spectrum, economists and environmentalists, because it has unrealistic goals. But it does provide an interesting framework for us to work off of going forward. I mentioned that there are a lot of myths around this. And President Biden released his climate plan in, it was either late March or early April of 2021, and it's actually very similar to the Green New Deal in its general goals, but it also includes stuff specifically focused on carbon sequestration technology, which is kind of interesting. So there is hope through legislation, through global action, right? If we want to solve global problems, we got to act as a globe. We can't expect to solve it on our own or expect other countries to figure it out for us. And if we look at this graph, we've got projections of climate change. So we've got time on the x-axis, and on the y-axis, we've got gigatons of global CO2 emissions. So currently, we're seeing this black line is the data that we have, and these for CO2 emissions, you can see it increasing, but it is leveling off, especially as we reach a carrying capacity of the human population as we approach 11 billion. And with current policies, projections say that we'll get about 2.9 degrees Celsius of warming by 2100, which is a lot if we don't curb our emissions. If we want to keep global warming below 1.5 degrees Celsius, we have to cut substantially. But right now, the most realistic, sort of optimistic scenario is this pink line here. And a big part of this actually has to do with the decisions that China has made very recently in 2020 around the COVID pandemic. They have set goals to work towards zero emissions by 2060, I believe. And they have a big fall of emissions due to the COVID pandemic, but China obviously releases a lot of CO2, but they're also the world leader for solar, hydroelectric, and wind energy. So they are transitioning towards that. So after all this, if you're still feeling any doubt about whether climate change is an actual threat, and you're possibly wondering, well, what if we do all this stuff, we make all these changes, we invest all this money, and it turns out climate change wasn't as bad as we thought it was going to be? Well, I guess we would have made the world a better place for no reason at all. Because in the end, the changes that we want to move towards, even if climate change isn't as bad as we think it's going to be, and I think it's going to be at least that bad, unfortunately, there are other problems caused by fossil fuel combustion, for example, such as air pollution, right? And transitioning towards an economy that is not based on fossil fuel combustion is going to help increase all sorts of ways of life for a lot of different reasons. So it is worth pushing for that. All right, there's a lot to unpack there, so we will talk in class over the next 2 days. Bring your questions to class, and I will see you then.